Oh, good morning for me, good afternoon, or good evening, depending on where you live. I'm Mickey Stewie. I'm a senior database developer at a local company, and I really like talking about T-SQL. Today we're going to talk about changing your habits to improve the performance of your T-SQL. A little side note for those of you who did come back last time, I had this idea for this presentation because I started off as an application developer, and the things I talk about in here, I wish I would have known back then. I would have been a better SQL writer when I was an application developer. So today we're going to have various objectives. We're going to start with some basic stuff about how formatting your SQL and being consistent across your team can help you troubleshoot faster. And then we're going to get into the nitty-gritty, everything from some small gotchas to how different forms of holding your data in table items like temp table, table variables, materialized table can affect the performance of your SQL. We're going to do the 3 different types of user-defined functions, cursors, and then we're going to end up of why SQL Star can be bad, not for performance, but for some gotchas that can affect the rest of your team's SQL. So the first thing I like to talk about is formatting your T-SQL for readability. There's some things that can be helpful for troubleshooting in the future. Brief comments, who wrote it and who worked on it last with some dates. The reason this can be helpful is if you're pulling up a start procedure or a view that you've never seen and you need to ask questions because there's some strange logic in it or you don't quite understand why maybe there's some nested views, you can go back to the last person who worked on it and take a look at it. When I first got to the company that I'm working at, they didn't have that. One team was actually putting their initials at the end of the view names. So underscore MRS would have been mine, and that wasn't very helpful. You don't know when it was created, and it's a strange pattern to have on your object names. Being consistent can also be very helpful because then you can troubleshoot faster. And of course, having a formatting pattern, having a set of standardized rules that your team will agree upon is the most important. I could have a set of rules that I like, and team member A can have a set of rules that they like, but if we don't find a middle ground, we're going to constantly butt heads, and we're probably going to do things that annoy the other person. So definitely make sure your team agrees on whatever standards you create. Now, I'm always asked, what are my standards? Because if you've never had them, you kind of need a point of reference to start with. I truly believe in spelling the words out. You can have some exceptions that could help. For instance, I'm in the financial area, so using the word FICO is a standardized name. I don't need to spell that out. But another word, oops, I pushed the wrong button. Let's try that again. Another abbreviation will not be helpful. Please don't put special characters in your names. No periods, no $signs, no slashes. The reason why, 2 reasons. One, it's hard to read, especially if you put periods. Spaces on either ends can be incredibly confusing. It also can break your DBA scripts because we pull scripts off the internet to help us do things, and sometimes you need to put a square bracket here, not a square bracket there, or it blows up. So that can cause them more time to figure out what they need to do. Periods are the worst because if you're doing a fully formatted table name, it can be database.dbo. and then the table name's got periods in it, and so you're like, is this a linked server? What exactly am I looking at? I like personally using capitalization. Some people like to use underscores to separate the different words. It all depends on what your preference is. Now, one of the things I did is I started educating my whole team, because giving them even just a 2-page document or 1-page document can be overwhelming overwhelming. So you want to make sure that they have buy-in slowly. And they may not ever read the document either. One of the companies I was at, I had a manager who was very adamant about excuse me, how we wrote our case statements. So I sent out an email and I talked about how we had to write our case statements this particular way, gave them the correct way and the incorrect way. It's obvious what the correct way was, but sometimes it's helpful for certain patterns to show what the obvious ways maybe you've seen when you've done code reviews. Is there any questions right here?
Not yet.
Okay. One of the other ways that I help educate my team is I send them important blog posts for several reasons. One, that can go more in depth on a particular subject, maybe a different way to write a cursor, maybe a different way, maybe showing them how to use row number to facilitate a different way of using the max statement. It also justifies why you've gotten particular rules that you want them to follow for better standards and better ways of writing code. Now you can provide templates to also help them write code. For instance, I like to have my code have an error handler, and if they're using transaction statements, I have a particular place I want them to put the rollback. You can make this really easy for them by providing parameters that they're called SSMS template parameters. You can put these less than, greater than with 3 values in the middle that will act as a placeholder. So you provide the field name. This is not exactly the field name it's replacing, but it's a descriptive field name like database name or table name, even author name. You then provide the data type. Most of the time I'm using string, although date can make sure they're putting our correct date. And this is an optional value called default value. So maybe 99% of the time you are using database ABC. So you can have that as a default value. Then all they have to do is use Control-Shift-M to invoke these parameters. The other great thing about this is, say you're referencing the database name 5 times in your template. They'll only be prompted 1 time for the database name, and it will appear 5 times after the Control-Shift-M. So let's take a look at a demo for this. Here I have one. This is the one with all of my error handlers and everything, and I want to ask the users to fill this out. So I'm going to do Control-Shift-M, and here it pops up. My database, I'm going to do AdventureWorks. AdventureWorks. I think I have 2008 R2 on this box. Schema, Sprock name, my Sprock. Purpose to demo this. My name and today's date is 3/8/2016. I hit OK, and it populates everything. Here I have wanted to see if it's a drop crate, which I only use in development. I don't want to use this in production because I can lose security that might be at the bottom of the procedure. I put a sample in here, and then I have my procedure name. Then I only had to type it once. They know that it's spelled correctly, and that's a very useful thing. Yes, I can provide this template for those of you that want one. I'm also going to step back and look at an ugly query at this point. This is one that I see often. They think they're organizing it by their select statement and their from statement. I find this difficult to read, and I also find this difficult to troubleshoot. So what would be another way that I would ask them to write it? Here I have indentation. Here I have the various tables, and hey, look, I didn't even see this. I have a subquery in my from statement. So, and this might, depending on how it was written, may be one of the areas that's slowing my store procedure down. So now I'm able to quickly troubleshoot it. If I don't have any tools on there, that might help increase the formatting. There is a free tool out there on the interwebs that you can take a look at that can help with some formatting. It does mean that they're going to be copying and pasting temporarily the store procedure into a website. It won't execute there, they don't store it, but you may have some limitations at your company that you can't do that. So let's go back to our slide deck. So now let's start looking at the nitty-gritty of the various ways of writing your SQL. And I'm going to move a window. You can't see it, but it is from the go-to site. So, top-down design. This is how application developers are taught to program. You do A, you do B, you do C. You might be using temp tables or table variables along the way. That is not always the best way to do your work. If you break it up into small of components, the optimizer isn't able to do its job to pick the best execution plan. Now, I'm not saying that that's the silver bullet and that you have to pick one Mongo SQL statement. There are times to break up the store procedure or the view in multiple parts. And that you can figure out by doing your testing and writing it various ways. After a while, you'll see patterns. Okay, when I work with these tables, I need to do this, and other times you need to do this. The most important concept that you really want to think about is narrowing your data quickly. I have seen store procedures where they've broken it up into multiple chunks because they needed to, but then they put all their predicates, all the things that would narrow the data in the very last SQL statement. So they've been carrying maybe millions of rows through the store procedure that are being manipulated when they could have maybe worked with 1,000 rows from the very beginning. So see, when you do have to break up your store procedure, or maybe you're using some other technique, try and narrow the data down as quickly as possible. The other thing that you want to do is start using set theory. Set theory is really what T-SQL is built on. So you want to think about how the data is joining. My BI team really loves left joins, but they're not necessary all the time. They also use, because they like nested views, I find that one table that's very wide gets used multiple times. So that's something that you want to look into and make sure that it's absolutely necessary. For predicates, these are your where statements. You want to take a look at how it's being built. For instance, there are different functions that work differently. Now, I don't know if you've gone through the path of looking at execution plans. There's some great books out there that touch on that topic or explain it well, not just touch on it. They go do a deep dive. And you'll find that most of the time, not always, a table seek is very beneficial. What it's doing is when a table seek works on a index, it knows that it needs to go maybe into the very middle of the index to get a set of rows because it has been filtered maybe alphabetically or sequentially based on some numbers. If it can't do that, then it has to do a full table scan. Now, if that table is really wide and very long, that will add to the length of time that it needs to return your data. So for the left function, it always knows to start at the beginning of the index to get the data, while the right function is utilizing the data from the end of the strings, which means it's going to have to do a table scan because the data is not ordered by the last end characters. Another one you need to be careful of is the like statement. Now, the like statement is great when you don't have, what are they called, lookup tables, because lookup tables will allow you to know that there's various strings that you need to look at. For instance, maybe there's 3 ways of writing your company name, but then that column also has 5 different companies, maybe they're your sister companies, and you want to grab all the strings that have your specific company in. That's where you would use the like operator. But that will hurt you if you have a wildcard at the very beginning, because again, you can't use the index and it will you won't get a table seek, and you will end up with a table scan looking at the entire table. Well, if you have a lookup table there, then you would just have to use the IDs, maybe 1, 5, and 6, and you'll get the 3 company names that you're actually looking at. And ORs are something you want to think about. The ORs aren't as detrimental as in older view editions. The in statement that can replace the or statement, or the and, not just the or statement, those are detrimental in older versions like 2000 and 2005. They weren't optimized yet. But if you're in 2012 or 2014, go ahead and use the in statements. They can be very valuable. But remember, it might be easier to use the lookup tables, to use IDs as opposed to strings in there. I love union and union all. They really help to facilitate looking at smaller chunks of data, especially if you have data in 2 different tables that you need to join. Now here's the differentiation between the 2. If you knew that the first select statement is definitely going to return different rows than the bottom select statement, then you want to use union all, because what it does is it's not going to check if there's duplicates. Union will verify if there's duplicates from that select statement and provide the unique row, just so that you only have 1 statement. Now, one of the things that I did is I wrote a different way of using it. Instead of using as null, I wrote 2 separate select statements and used union all to join that data. It is not, again, the silver bullet of replacing as null with the way of using union all, but is an alternative to doing it, and it could help with performance. You just need to make sure you're doing the testing. I'm going to take a sip of water because I've been talking for a while. Are there any questions at this point?
There are a lot. So can we save them for the end?
Yes.
Okay.
Another note is I will group the questions into various categories, and I'll blog for the questions we don't get to. Last time I had 2 separate blogs that I had to break up. I may not do this time. I may just do the really pertinent questions and when I mean pertinent, I mean that were covered in this section. In this presentation, I'll blog about them, and then for those that I really need to know this, you can email me if it didn't end up in that blog post.
Perfect.
So, implicit conversions. These appear when you're comparing 2 columns with different data types, and you can Google data type precedence with the word TechMech, and it will provide you the list of precedents. It's just like math, where multiplication and division will occur prior to the addition and subtraction if you don't use parentheses. In this case, you need to use either the convert statement or the cast statement. They behave for performance the exact same way. Now there is another one that you can use called, I always get the name wrong. It sounds like correlation, but that's not it. Hopefully it'll come to me in a few minutes. But basically what that does is it says if the first one is null, go to the second one. If the second one is null, go to the third one. And it will do that n times until it provides a value that is not and is null. So implicit conversions can hurt you because they might give you the wrong data. Even if you're comparing a varchar to an nvarchar, it's going to cause an implicit conversion. So let's take a look at those. I'm going to turn on set statistics IO on and the time. and I'm going to show you the data so that you know what we're working with. I have data in here. I have numbers as a text string and as a number. I also have dates as a date and as a text string. And now we're going to start comparing them using implicit conversions to see what happens. Now in this first demo, I am joining it to a dim date table. All this is a table of dates broken up into year, month, quarter, so that you can grab data based instead of using ranges or using the year table. This table is used quite often in data warehouses, but sometimes it's helpful in your transactional database. So I've joined the date table based on the date string, the date data type, and then the text string. And I'm looking for all the data in 2005. Now here you can see that I have the first select statement returned 23,000 rows, and the second string, the second data set also returned 23,000 rows. So they're returning the same data. We would have to actually do a row-by-row comparison to verify that they did actually return the same amount of data. Now here you can see that we had to do 5 scans on the dim date and 5 scans on the test data, while we didn't have to do that on the second statement. Here we only have 1. There was also a different amount, although it's close, 312 milliseconds and 344 milliseconds. Now while these are pretty close, they will be different on actual select statements. Here my data is pretty simple. I'm also going to turn on execution plans. So let's take it the next step. Here I'm looking at a range of dates instead of using the year function, or the year column out of my dates table. Wow, very different results. The first one returned the 23,000 again, and we got absolutely nothing in the second set. And why is that? Let's take a look. We can analyze the data up here. Let me bring it down so you can also see the select statement in the second select. I'll take a sip of water so you can see if you can find the difference. Actually, a sip of coffee. So the difference is we are comparing text to text, while up here we have text to a date, and it converted this text to a date time variable, or a date data type. Now if you look at the text, it's starting with 2005 as opposed to the month. Texts are alphabetically and numerically compared as text, not as numbers. So 1/1/2005 would not be equal to 2005/1/1, as also there's slashes and dashes. So it does not have the same values. So you're going to have to be very careful if you find dates or numbers in your tables. Here I could have fixed this by converting this to a date data type on both of them, or maybe using a variable. So now when I run the second statement, I get data as opposed to getting no data. Let's take a look at the second one. Now while I'm using a 0,1 compared to the string, and here I'm using 0,1 as a number, mathematically we know that the 0 drops off because it's not needed. So, oops, wrong button. Here I can see, if I can pull this up, the first one gave me 190,000 rows, while the second one gave me 19,000 rows. Again, because it's doing a textual comparison as opposed to a numerical comparison. Now, how can I also verify that I have implicit conversions going on? When I look at the SQL statement of the first one, nope, that one's not being as helpful. Let's try the date one. They're in there, I just don't want to dig as deep for it. Now, if you are in 2014, you're going to get an exclamation mark because we have an implicit conversion. So up here, it's not telling me today. What about here? So we can go into the properties window and we can look here for the warnings. And under the warnings, it's telling us that we have an implicit conversion. If you are brave and you like XML, which most of you probably don't, you can go into the Show Execution Plan XML and search for implicit conversion, or implicit. And it will also show you that you have an implicit conversion that you need to go and fix. So let's take a look back on my slide deck. Oh, wrong button. Before we go, we could see that data types matter and you may not get what you expect. So it's really important to make sure that we are looking out for implicit conversions. Another water break. I always don't want you to know that I'm silent, especially after us losing the last presentation. So we really have three different ways of putting table in a structure temporarily as we're working. The temp table will starts with a hashtag. The table variable we define like any other variable, and it will have that sign. Now, materialized table, a lot of people are like, what am I talking about that? That's actually one of the more formal names for a normal table that is stored in your database. This one can be dangerous if you're working, if multiple people are referencing it, because the data will move around and they might overwrite your data. Materialized tables are used quite commonly with SSIS packages, but you're going to want to make sure that that SSIS package isn't running multiple times at the same time. Now this statement right here between the temp table and the table variable, there are some urban rumors that table variables are stored in memory. They are not. They are also stored in the temp DB, just like a temp table. And we'll see how you can verify that. Now, while you can index a table variable, it's not going to do squat. The reason for that is table variables, the assumption is there are very few records. Prior to 2014, it assumed there's only one record in the table variable, even though you could have a million records. And that will affect your execution plan. Temp tables can be indexed, but that can cause your stored procedure to slow down. And when I mean stored procedure, I'm also including views in here. I'll have to differentiate them. Temp tables, because what it's doing is it's indexing on the fly, while a materials table stores the index so it doesn't have to recreate it. I already covered this about each person having their own, and I also covered the estimate. So let's take a look at some things that they're good for. Temp tables are good for when you need transient data. Maybe you need to break up your stored procedure. You can't use them in views, so that you can break it up and work with less data. Maybe you have 15 tables that you need to work with at one time. For table varies, I'd put very small amounts of data. I usually do 10 rows or less because, again, it's going to assume there's only one row in that table variable. And that's the next slide. So let's go back and take a look at our demo. Here what I'm doing, Control R, no. Here what I'm doing is I'm going to make sure I'm using the best database, the correct database, and to see that I have 1 million rows in here. I'm then going to go ahead and turn on the execution plans, and I have three different ways of using the data. I have a materialized table, a table variable, and a temp table. I'm going to just load all that data into all three structures. I'm then going to go ahead and, this is the inserts that I talked about. I'm going to set statistics IO and statistics time on, and I'm going to simply run the same select statement for all of them. So let's go ahead and run that. And it'll take a few seconds, which means a coffee break. For me, it's, what time is it? My clock is still on a different time zone. So it is 8:30 for me in the morning. And let's take a look at the data. It's bringing all the same data back. For the messages, we can take a look at how this worked. Now for the temp table, it's creating a very long name. That's so that it can take a look at, in case you run the same stored procedure over and over again. We have 5 scan counts and 5,000 reads. On the next one, we have, oh, I'm sorry, that was the materialized table. Oh, no, that wasn't the temp, sorry. We have the temp table, the materialized table, and now we have, this is just the materialized table that we saw. We have the table variable. Here is the name of the temp table that it used. So now let's go ahead and look at the execution plans. The first one is for the materialized table, and we can see what's going on. It's got a very nice execution plan. Down here, it's using an index scan. While these are looking like they are faster, they're very short. They're not. They're taking, this one, the batch is taking 4%, while these, the rest of them are taking 29%. And look here, it's telling us that we need to have a different index. So let's go ahead and continue on. So user-defined functions. When I first saw these come out, I thought they were the best thing since sliced bread. Again, coming back from an application developer's background, you are taught to break up your code for usability and for readability. So scalar functions do have a good use when you are doing some mathematical operations, but not when you're joining tables. Why is that? The joins will be repeated for every single row. The reason for that is your scalar functions are, the majority of the time, they are going in your select statement, or they might be going in your where statement. So if you have 1,000 rows being returned, that scalar function is executing 1,000 times, and if there's a query plan in there, you're going to see it be executed 1,000 times as well. Unfortunately, you will not see that when you pop open the results of the execution plan. You need to either use a profiler or extended events to see everything that's going on. A multi-line table function is a user-defined table function that has maybe some declare statements, maybe some separate select statements, and it is only going to be optimized for one row. Why is that? It returns a table variable. Inline table functions are going to have a single select statement. No declare variables, no multiple select statements. You have to encapsulate it in one select statement. You can use CTEs in there, which is really nice. It does not return a table variable. Think about it like a temp table. When you look at your execution plan, you'll see that the tables that were utilized in the table function, inline table function, are embedded in the outer select statement. but it is not the answer to everything. You might find that a subquery performs better or a CTE performs better. So again, you need to take a look at what's going on in your query or view. So let's take a look at the next demo here. I'm going to turn on Statistics IO, and I'm also going to turn on the execution plan. So I have some start date and an end date. They're going to convert it for a date, so we don't have to worry about implicit conversions. I have a scalar function here. Let's take a look at the inside of it. We can see that the inside of it is doing a select statement on a table from Adventure Works called Sales Order Header. The other user-defined functions are set up identically. So let's take a look and run that one. When I look at the execution plan, what do we see? We do not see that other table that we saw in the scalar function. It's obfuscated or hidden. So let's take a look at the second one. I'm going to go ahead and run all of them because my variables are at the very top. The first one again is the scalar function. Here is the table variable being returned right here. The next one we see is the inline table function, and here we can see that the sales order header table is being shown in the execution plan. And the last one that I ran, this one is actually using a subquery. Now you see that the last one is, the batch says is taking 50%, but that's not actually accurate. It's looking at what is actually being returned. So while this one looks like the batch is the smallest, again, there's things that are being hidden. So let's go turn on an extended event that I already set up. That is stored in management, extended events, sessions, and tracing a SQL query. So I'm going to go ahead and start this session. And this time I'm just going to run the scalar function at the top. I apologize if you can hear my phone ringing. We don't even answer that anymore because it's all ads. So now let's look at the trace events for the SQL query. Watch live data. We need to run it one more time. When I look at the extended events, it is not doing what I wanted it to do this morning. Oh, there they are. They're popping up slowly. And it's still not doing what I wanted it to do. So let's go ahead and start Profiler because I have that on here too somewhere. I'm going to go ahead and do a template, I think. Open. I have one called, I think this is the one I want. I'm going to go ahead and run it, and I'm going to clear this out, and I'm going to go run my store procedure again, and my query. And we're going to go back to the profiler. And again, it's not doing what I want, and I apologize for that. We'll see if we can get it to work if we have some time at the very end. Oops, that's where I wanted. No, I want to go here. So cursors, why are cursors bad? They're executing the same code over and over again. So if you're processing, say, 30,000 rows and you need to have 40 iterations, you're going to get over 1 million rows processed. The scalar functions we saw can do the exact same thing. What are some other options? Oh, I also wanted to point out that while loops behave the exact same way. While loop is just another way to write a cursor. Now, scalar functions are not cursors. They just perform like a cursor by reiterating the same code. Some other ways to write it are CTEs. That, again, is not a silver bullet. They are called recursive CTEs, but they can be very helpful to replace a cursor. If you've not looked at cross-apply or outer apply, definitely look it up or send me an email and I'll explain it. They can be very helpful for giving the same options. Someone sent me an email the other way asking to help utilize a cursor, and that was one of the ways that I helped solve the problem and helped write it better. Subqueries is another way that might be beneficial. Now, if you've never heard of a tally table, all that is a table of numbers. You could have 1 to 100, you could have 1 to 1 million. By joining to it, you may be able to utilize those extra rows to work with cursors or maybe find a range of data with some holes. There's some great articles out there. You just have to Google for a tally table or a numbers table. So let's go ahead and look at a demo for cursors. Here I wanted to show you what the data is. So all this is a table with strings that have comma delimited that I want to separate into individual numbers. Here I have a cursor. I declare the cursor, and I have in this one I have a CTE with a union all, and it's going ahead. Oh, here's the first one, sorry. I have the select statement that's parsing the data. The second one, I'm using a CTE to do the exact same work. This is what the inside of a CTE looks like when you're writing a recursive CTE. The third one is a while statement. It looks very simple, but it is circling around each time to do that recursive action. Here I have a scalar function that is separating them out. This is an inline table function using the cross apply, which means it's going to work on that whole table and return it at one time. So let's go ahead and run all these. And let me do that with the execution plan turned on. So we can see all of the various data being returned. I summed the numbers after I separated them. Now it looks like it is being quick, but it executed it multiple times. We can also see that in the execution plan by going ahead and showing it multiple times. Oops, that was the wrong button. Oh, it just has a lot of space down there. And we can see that it's executing multiple times. Wow, running all of that. I only showed you, I think, 4 queries, and we've got multiple query plans all the way down to the 44th. Now this is the very bottom one where we have a inline table function, and we have a single execution plan. Up here was the table function, the scalar function. Again, this is the one that's hiding all the data, and it looks really simple, but you're not actually working with the data. We can go ahead and look here. Again, this is on the inline table function. We can see that it's much longer than the scalar function. If we go back up here, these are the ones that were constantly going around and around. Now let's look at the messages. This one had 2 logical reads, a scan. This one we needed to look at a work table as it's going around and around. Actually, let me run those separately. It'll make it look a lot easier to see. This is the first one. This is the cursor. And it's returning all the data. So it's going ahead and working each time. So this was the first time it executed. And this is the second time that it executed. And all the way down. We'll see the while statement will be very similar. Again, we can see that it was executed multiple times. And you would have to sum all the scan counts and the logical reads in order to see that how many you are actually processing. Now again, we're going to see that you won't see much in here because it's hiding everything. We don't see that it was working with numbers to parse them out. But when we look at the inline table function, we'll see that everything was worked out and we have quite a few more reads because it is still recursing, being recursive. So let's go back to our last slide. Why is select star bad? Again, I see this all the time, and it's not really performing poorly, but it can do unexpected things. For instance, if you're returning all the values and you're grouping them, that will break because an extra field that was not put in the group by appears. It can lead to poor execution plans because you can't use a covering index. Maybe you were trying to use a covering index with 5 different columns. You add a new column and now covering index anymore. It can also break if one of the fields goes away. Maybe you have that in the group by even though you weren't utilizing it. Now it's going to break no matter how you work it, but it would be harder to find. So let's take a look at a select star. So here I am returning the same values. Great. And down here I have the same values that I'm doing a group by. Oh wait, what happened? There's a new column. This one wasn't expecting to have a new column, while this one, that one wasn't. We can expand this. These were actually the only columns that we wanted to work with. So now if we execute these two, let's drop the column. And it is 2. That was the one I wanted to utilize. Again, I apologize for this. That's what I wanted to start with. So here when I run this, it brings all the data I expected. But when we add a new column, data type may be int. We've added the new column, but now it's going to break it because it wasn't expected. It would also, maybe I have this using a covering index and it will no longer utilize that. So in this session, we talked about from the very beginning where we're going to help troubleshoot and provide a uniform way of reading code to make it quicker to troubleshoot and look at various and look at your code. We then started going through how we need to use set theory and how we need to look at maybe the left function and the right function. And what you wanted to do there is consider maybe rewriting your where statement to utilize the indexes appropriately. We saw implicit conversions, table functions, cursors, and finally how the select star can affect our outcome of our data. So we already saw that we have a ton of questions. We have 6 minutes, or actually 8 minutes. So are there a couple questions that you wanted to cover, Liz?
Yeah, are you able to see the questions or no?
No, I hid it because it was affecting my screen.
Oh.
So let me expand that out.
Might be easier for you to pick through them and decide which ones might be best to apply for all.
I only see one question right here.
Okay, I'll run
would I be able to get, asking if you can get the recording and the templates. Yes, you will.
Okay, let's see. What about stored procedures run in SSIS packages? You can't use temp tables, so you must use table variables and they are slow. Are there any alternatives?
When the SSIS packages executing a stored procedure with a temp table?
Yes.
I haven't tried that because I haven't had to utilize that. I thought the SSIS packages could execute any stored procedure. So I'll tell you what, I will test that out and email me your email so that I can get back to you on that.
What about the use of T-SQL formatting tools? Do you have any that you could recommend?
Yes, I do. Go ahead and email me there. I think you might be able to write or Google formatting SQL. It's really simple. It's a text box. You put your SQL in there and you hit a button and it goes ahead and format it. I don't think you get to pick what options. My team was using it. I have another tool, but I can't talk about it in this presentation. There are several tools out there. Some of them are free for older versions and others you have to pay for them. Again, I'll put that in my blog post.
Okay. I've always had the end at the same indentation level as case. Does this matter?
Nope, that's all based on your preference. I like them lined up as well. The formatting tool I use doesn't really give you an option for either way. So when you are using various formatting tools, whether it's a free one or paid one, I find it easier on the team if you don't make them go and change small little things because your formatting tool didn't let you format it for your preference. They really don't like having to go back in after they format it and format it a specific way.
Okay. What do you think of common table expressions?
I like them. There is a blogger out there who doesn't like them at all. There are times that subqueries are faster. It kind of depends because there is a little bit of overhead using a CTE, a common table expression. But for the queries that I've worked with, I haven't had that issue. It's also easier for more junior people to read the query using CTEs because they see that breakup without actually breaking up the query into multiple statements.
Okay. Can you provide examples of using all to replace if it's null? Does that make sense?
Oh, it is null? Yeah, I'll put the link to in my presentation, or sorry, on my blog. I actually have that as an article, so you can look it up on my blog. While we're answering the questions, I'll go ahead and show all my contact information. Then we'll take one more question. MickeyStewie.com is my blog, and under resources you'll be able to find the slide decks. I'll also give them to Liz. You'll be able to email me. You can also find me on other blog sites, and you can follow me on Twitter. I talk a little bit more than SQL, but when I read blog posts, I post it on SQL that I read them, so that you can also read the blog posts that I happen to be interested in. Sometimes they're not T-SQL, sometimes they're really deep, a deep dive into the SQL Server. But I'll put a link in my blog post to that particular article so you don't have to dig through my blog site.
Okay. All right. Can you review the difference between what temp tables, table vars, and materialized tables are used for?
The materialized table variables I would only use when I'm working with SSIS packages if I'm putting temporary data in them. Otherwise, a materialized table is like all your other tables. For instance, we saw a sales order header table that has the transactional data. The table variable is the one that the optimizer is only going to assume you have one record in there, even though you could have 1,000,000 records in there. So you want to put a very small amount. I usually use no more than 10. There's other people that won't use more than 100. The temp table would be to help break up your stored procedure. Maybe you're joining 15 different tables, and it makes sense to break up the data from those tables by using a temp table. Temp table and table variables can't be used in views, but they can be used in other SQL objects.
Okay. Sorry, I'm scrolling through everything.
It's okay.
Can you supply more explanation on why cross-apply has good performance?
Not right this second. It's a little longer, so I will put that in my blog.
Okay, someone wants to know if you use an SSMS add-in for formatting code. If so, what is it?
Yes, I do, but I can't talk about it in this presentation. I'll talk to Liz to see if I can put it in that particular blog post.
Okay. Okay, how did you expand the star from the select star to list all the columns?
Sorry about that. That's another tool.
Okay, no problem. I'm guessing anything with the SSMS you can talk about in your blog, correct?
Yes.
Okay. Why and when do temp tables and CTEs perform differently?
That depends on the query that you're writing. The CTE just has a little bit of overhead, but the data is being held in memory, while the temp table is actually being written to your temp DB. If you, I'll talk a little bit more about how the temp DB works in the blog posts. I don't want to give you inaccurate information, and I need to review that outside of right now.
Okay. The top-down approach is unclear. Can you brief on it?
Yes. What I'm talking about is breaking up a query into multiple select statements. So if you have a query that is maybe working with 15 tables and it's going to return a million rows and it's got really bad performance, so you might want to break it up into multiple statements. But if you work with it, say the first query you don't put a where statement, you just join everything to it. The second query, and you put in a temp table, and then the second query you join maybe 5 more tables, that maybe narrows it down to 3/4 of how much data you're going to have, and then put back into maybe a different temp table. And then the third one is where you put all your where statement, and now you're only returning 1,000 rows. If it was possible to put that where statement at the very beginning, maybe it returns 2,000 rows, and then in that second one it returns just 1,000 rows, and then the final one maybe manipulated the data and still returned 1,000 rows. That would have been a better top-down approach. The second one is maybe breaking up the data, and you didn't actually need to put it in the temp table. Maybe it was only 3 tables and someone was just working with each table separately and joining the temp tables at the very end. And I have seen usually application developers will do that because they really have it ingrained for working top down by breaking up everything into smaller segments. And I don't mean to make it sound like application developers write bad SQL. That's just the way that we were taught for working with maybe our C# code or another language.
Okay. I have a long while loop evaluating and removing name suffix substrings in a scalar function that accepts a string and returns the new string without the suffixes. What would be a faster set-based method to accomplish the same goal?
So this sounds like the scalar function is doing the work. You actually can just remove the prefixes using I think it's replace. If you know how many characters it is, then maybe it's just 3 characters. Then you could use replace to, I think it's replace or substring. There is a function, I could put that in the blog, and you could say 3 characters and replace it with an empty string, and that will remove it, and then not use that scalar function. It may also be able to be done with a inline table function with the cross apply. That specific one, if you want to send me a sample, maybe get permission from your boss that you could send me the exact same SQL so that you don't get in trouble, or maybe write a similar one using fake table names, and then I can send back an example of that. I did that for another person. I won't put it in the blog without your permission.
Well, we have gone over on time, and I know we all have things to do. So I know we didn't get to all the questions, so Mickey, I'll be sure to send you those so you can include them in the blog. As always, you'll receive an email tomorrow with a link to the recording, and follow us on social media to kind of stay up to date on when we post Mickey's blog information. And if you have any questions in the meantime, Mickey's contact information is up there on the screen right now. And if for some reason you forget it or you didn't get it, you can just email me, Liz. It's the email that comes with all your GoToWebinar stuff, and I'll be happy to pass along those to Mickey. Thanks again, Mickey, for doing this for a second time. I'm glad we got through it.
Yes.
And we hope to talk to everyone soon.
Yeah. Thank you.
Thanks.